Alright class, so in the last class we have started and completed triangles law and polygon law. Before we begin with resolution of vectors, see, resolution of vectors is a very important topic, resolution part, because random angles will be given to you and you need to resolve it. So before that, one question is left from this section that I'll give you. Just try it once yourself, take 2 minutes, then I'll discuss it with you. Then we'll start with resolution of vectors directly. It says if A plus B's magnitude is equal to A minus B vector's magnitude, then you have to calculate angle between A and just see what's the angle coming. So A plus B's magnitude is equal to A minus B's magnitude. C class, how will we calculate this? A plus B is magnitude. How do you add two vectors and take out their magnitude? Simply you write the resultant using parallelogram law or any law, triangle law, polygon law. What did we see? We had seen that in all of these laws, ultimately, you have the formula left as this only. A square plus B square plus 2AB cos theta. This is for addition. Now class, everything remains the same, but just we have negative sign for subtraction. Subtraction of vectors I have not discussed it with you. We have a topic, subtraction of vectors, that I'll discuss with you. Just the difference that will come now will be here only. A square plus B square minus 2AB cos theta. Fine. So you see, if you square both the sides, these square roots will get cancelled. What will be left? A square plus B square plus 2AB cos theta. Here also A square plus B square minus 2AB cos theta. A square, B square, B square. All these terms will get cancelled. Now see, just bring this 2AB cos theta over here. This becomes 4AB cos theta. This is equal to 0. It means cos theta is equal to 0. At what angle is your cos theta 0? Yes, class. What's the value of theta for which you get cos theta as 0? 90, exactly. So the angle between these two, A and B, this is 90 degrees. So you can even learn this answer because in the MCQs also, if anywhere it is asked, this is used a lot. So 90 degree, you can even learn it. Fine. So note this down, then we'll start with the resolution of vectors. Written? Done, class?
Yes, done.
Let's start with resolution of vectors. The resolution of vectors means what? A single vector is present and you are resolving its components into different directions according to your needs. You will be coming across certain questions, especially in your lesson laws of motion. Inclined planes problems are there. So you have to resolve the particular vector that is acting in a random direction along the plane or perpendicular to the plane. You have various forces present in nature that are not directly straight present, or they are not standing in your position towards your y-axis. They can be making a random angle. If your force makes an angle of 60-degree, then which component of force will you use? What will be the value of force will you use? Will this 60-degree not affect your force at all? Will this 60-degree that your force is making with any of the axes not affect your final answer? Obviously it will affect, because if something is like this and it is producing its effect, something is now like this, obviously effects will change. So this was just an example of force. Similarly, you have so much different vectors present. You have velocity. If I say a car is moving on a straight road with a certain velocity, 5 meter per second, 3 meter per second, any of the meters per second, as soon as I say that that same car is moving on a flyover with certain making angle that the flyover is making with the road, so obviously there will be a change in the velocity of the car that will be executed. There will be either a decrease or increase in velocity depending on how much inclination is present. So that's why in nature we have to resolve certain vectors for our calculation specifically. For your theoretical point of view, you can even analyze things and answer them. But from your theoretical numerical perspective, you have to find out the exact magnitude. So to find out the exact magnitude, you have to have the idea of whether the force is increasing or decreasing. Or even let's say a force is not acting towards x-axis, it's not acting towards y-axis, it is acting in xy plane. XY plane, you understand? This is x-axis, this is y-axis. So this whole plane is known as xy plane. So if a force is not acting like this, it's not acting like this. It's acting in a random direction like this. So xy plane, both the forces are there. Will you use I cap or will you use j cap? If it is pointing towards, we have done universal vectors. So if it is pointing towards positive x-axis, you will say it is I cap. If it is pointing towards positive y-axis, you'll say j cap. But what if it is making an angle, random angle with the x-axis, and it is pointing towards any of pointing in this xy plane? Then will you use I cap or j cap? That's how you can analyze that there will be a difference in your answer. So this is the process of splitting of vectors into its components. It's the process of splitting up of vectors into its components. Its components acting in different directions. For example, I'll give you an example. This is your random vector A. Fine, this is a vector A that you have. Now, A will be having a component, let's say A1. It is having another component, let's say A2. And the angle between the components is theta. This is a random example. This is not how you will resolve vector. How to resolve the vector, that I'll tell you. This is how you do. So this is, and especially Maha and Fatima, you especially pay attention to this resolution part, because in laws of motion, resolution of vectors is required a lot. So component, this is component of A. This is also component of A. But A is actually what? This vector A is made up of A1 plus it is made up of A2. 2. This is what you call the process of resolution of vectors. Now, how the rectangular components are broken. See, this is resolution of vectors. You can resolve the vectors. But in physics, and physics for your level, you
Ma'am?
have rectangular components. Yes.
The laws of motion are cancelled in our school from our portion.
Laws of motion is cancelled.
Yeah, ma'am.
All right. So, which all lessons are coming then? I think somebody wrote laws of motion also.
Ma'am, it's not there.
It's not there.
No.
No, ma'am, we have only the second chapter, the third one, and the fourth one.
All right, all right. So I think it must be
Ma'am?
somebody else. Yes, Aram.
It's for me, laws of motion.
Okay, so you had sent me the syllabus for the
Yes.
first step. Okay, fine. I thought it was Maha who sent the message. Fine. So Aisha, same with you then till laws of motion it is coming, no?
Yes, ma'am.
And Aram, you mentioned the date. What was the date?
17th.
17th. See. So Maha and Fatima, you will not be needing classes for laws of motion. Rather, Aisha and Aram. So this is what is meant by resolution of vectors. You are resolving the vectors. Now in your syllabus, you have rectangular components. Rectangular components. Now rectangular components means what? Rectangular component means, so you've understood what was A1, what was A2. A1 and A2 were just the components of A1. If you have, let's say, you have 7 Newton force. For example, let's say A1 and A2 was what? Let's say, for example, you have 7 Newton force. One of its component is 4 Newton. One of its component is 3 Newton. So ultimately what will happen? 4 Newton, 3 Newton. 4 Newton plus 3 Newton will make up this 7 Newton. Right? These two will make up this 7 Newton. So these are the components. 7 has been split into 2 of its component. That's what we call as component. Regarding rectangular component, if both of these are perpendicular to each other, 4 Newton and 3 Newton, if they are perpendicular to each other, then you say they are the rectangular component. Rectangular component means components which are perpendicular to each other. If I say this is 7 Newton, this is 3 Newton. Mathematically, this is incorrect. This is just a random example that I've taken. Instead of 7, it should have been 5. Because when you will solve under root 3 square plus 4 square, it will give you 5, not 7. So this is actually incorrect what I have written. But it was just a random example to explain you all. Fine. So now, if 4 Newton and 3 Newton, these are perpendicular to each other. This can be any angle. This can be any angle. But this angle between the two components, this is perpendicular, then you say these are the rectangular components. Fine, that is what is meant by rectangular components. If the components that you have broken are placed at 90 degrees to each other. So rectangular components are the components which are perpendicular to each other. Let's say this is some vector A. Now, throughout your physics, 12th physics even, you will be just requiring rectangular components. Forget about any random angle that is made between the two components. You are just concerned with the fact that you just have to know the knowledge of rectangular components. Now see here what will happen. A is a vector. So this is x-axis, this is y-axis. Let's say A is making an angle theta with the x-axis. Now what happens? The axis with which the angle is made that we term as the cos component. Fine. And the perpendicular to it, or the other component to which the angle is not made, we use sine component over there. I'll write down this also. Angle with axis, you will use cos. Then perpendicular to it, you will use sine. Fine. Now see, I want to resolve this. How will I resolve this? I'll actually resolve over here. What did I tell you? You get cos component. So tell me class, by looking at this figure, this example which I've mentioned, is the A vector making angle with x-axis or y-axis?
X-axis.
X-axis. So you will be having component of cos. Cosine will come. So here in this direction, this is one of the component of A. This becomes A cos theta. So A's component along x-axis, AX will be A cos theta. And the other one, which is perpendicular, this AY, this is A sine theta. Fine. So A cos theta, A sine theta. This is how you do it. I'll give you one more example. It's not necessary that you use cos theta with x-axis. You just have to focus theta with which the axis is being made. For example, let's say this example. This is y-axis, this is x-axis, fine. This is your vector A. This is theta now present. What did I tell you? The axis with which theta or the angle is made, you choose that as cos. Here y-axis is making angle theta with the vector A. So along this direction, along y-axis, you will be having AY will be equal to what? A cos theta. This time it will not be equal to A sin theta because angle has been made. Here, the other one, AX, this time this will be A sine theta. That's how you resolve components, vectors components. Fine. Remember, you will choose the perpendicular components only. Other components apart from perpendicular one are not included and they won't be even used anywhere. They will not be used. Fine. So this is how you resolve it with the help of one question. That's a very famous question that comes in most of the exams that I'll discuss, but I think before that, just note it down. Then we'll discuss that question. Through that question, I think more things will become clearer. See, this is a question given and you have to find out the net force. This is actually, this is a question of laws of motion. But this is when you calculate and when you solve this is in reality a question of your resolution of vectors only. Because no concept of laws of motion will be required. F1 is 30 degree. Take F2 is 37 degrees. Now see, here we have to resolve all the components along x-axis or y-axis, because we have studied if we have all the forces along x-axis, y-axis, then we know how to solve. We are having issues when it is apart from it. Resolving the first component, beginning the first component. See, just forget everything that is present. Just only look at F1. F1 force, that is 10 Newton. It is making an angle of 30 degree with the x-axis. So at this x-axis, you will be getting two components here of F1. One component will be here for F1. Right, class? This is F1. Two rectangular components will be obtained. Now, which will have cos theta, which will have sin theta? Angle is made between the vector and the x-axis. So your x-axis will be having cos theta. Please do not forget this fact. When to put cos theta, when to put sin theta. So here this becomes F1 cos theta. Fine. And this becomes F1 sin theta. First tell me, is this clear to you or any doubts in this step? Clear? No. What about others? Fatima, Maha? Yeah?
This one.
Now, see. Let's resolve F2. So see, similarly, F2 is in the second quadrant. There will be, this is F2, there will be one component along the x-axis, there will be one component along the y-axis. Fine. So there are two components of it. Angle is made with, again, the x-axis, the negative x-axis, angle is made with the negative x-axis. So this angle is made with the x-axis, so you will be having cos theta along the x-axis only. So this becomes F2 cos theta. This is actually, take this as theta 1 if you want, you can take this as theta 2 because both the angles are different. This is 30 degree, this is 37 degree. And this becomes what? This is F2, this becomes F2 sine theta 2. This is your theta 1, this is your theta 2. Fine. So F2 was there, you have resolved it into its two components. Angle is made here, so this is cos, this is the perpendicular one, so sine. And do we need to resolve F3? See, F3 is lying exactly on the y-axis. So F3 is not troubling us, we need not resolve it. Now we have all the forces along x-axis, we have all the forces along y-axis. Let's even put the values of these. F1 cos theta, what is F1? F1 is 10. Cos is cos 30 degree, root 3 by 2. So this becomes 10 root 3 divided by 2, which is 5 root 3, right? So this is, now this is your forces component along the x-axis. F1 sine theta will be what? 10 into half, which will be 5 Newton. So this is 5 Newton. F2 sine theta 2. See, for cos 37 degrees, you have 4 by 5. And for sine 37 degrees, this will be 3 by 5. And if you have 53 degree, then it gets reversed, it gets in opposite order. Here we have F2 sine theta 2 first, and you have F2 sine F2 cos theta 1. See, F2 sine theta 2 will be what? F2 is 5 sine theta 2. So sine 37 is 3 by 5. So 3 by 5 will give you 5 only. This will be also 5 Newton. And this is what F2 is, 5. Cos theta 2 is 4 by 5. This will give you 4 Newton. Now we have all the forces along X and Y axis. I'm writing all the forces separately. Pay attention. And wherever you have not understood, please stop me and ask me to repeat. I'll repeat it for you. C class. This is your X-axis, along X-axis. Along X-axis, now we have what all forces? We have the cos component of F1 along the positive X-axis. Fine, so F1 cos theta. Here you have a positive component and whose value is 5 root 3 Newton. Clear? Wherever you are having confusion, stop me and ask me. Fine, so this is X positive X-axis run. Negative X-axis, what all forces are there? Only F2 cos theta 2 is there, that is 4 Newton. So here along the negative X-axis, I have 4 Newton. Fine. Along the positive and negative y-axis. Let's talk about the positive y-axis first. See what all forces are there now on your positive y-axis. 2 forces are there on the positive y-axis, 5 Newton and 5 Newton each. So this becomes, here you have 5 Newton and another 5 Newton. And in the negative x z axis, we have only a negative y-axis, we have only 2 Newton. Yes.
Ma'am, one of them is 5 Newton and the other is 3 Newton.
One is 5, one is 3. Oh, this one is 3, right. This one will be 3. Thank you, Aisha. This is 3, so 5 and 3. And you have 2 Newton over here. Tell me, we had the 2 forces F1 and F2 in the XY plane, positive and negative. Now we have all the values of force either along y-axis or completely along x-axis. Any doubt still here? Aram, clear to you?
Yes, ma'am.
All right, then if this is clear. Now see, net force along y-axis if you calculate and net force along x-axis if you calculate. So if we see net force along x-axis, just the x-axis, 5 root 3 is pointing towards one side, 4 Newton is pointing towards the other side. Both of them will get subtracted. So net force along x-axis. So net force along x-axis will be what? 5 root 3 minus 4 Newton. So this will be what? This becomes 5 into 1.7 something. 1.732 minus 4. This becomes what? 8, around 8, no? 5, 10, then 15, yes, 8.6, around 8.6. 8.6, just check once. What's the exact value you're getting? So this will be a 4.66. Fine. So approximately 5 Newton only, but 4.66 Newton you're getting. So this is the force along x-axis now. So the whole wide forces that you had, that was spread, the 2 forces that were spread, now they are not spread, they are just combined into x-axis. Same with y-axis. See, Fy, if you talk about, if you calculate Fy, these two are acting in the same direction. So 5 plus 3, 8. And in the downward direction, this becomes minus plus. I'll write down the whole statement, otherwise it will be confusing. This is we do in the manner, no, we used to write the sign convention. One as positive, one as negative. Similarly, that we do. Like 5 and 3, they are in the same direction. So let's say both of these are positive and minus 2, like this, fine. So this becomes 6 Newton. You have Fy with you. Now, if you have the values of fx and if you have the values of fy, now resolution component part is over. Now this is done. What's left? Now you just have whatever you've studied earlier than this. It's like you have fx force with you, you have fy force with you. Definitely these are rectangular components, so they'll be making angle of 90 degree. So net force will be under root fx square plus fy square. So f net will be what? Under root 4.66 square plus 6 whole square. This is the value of force we're getting. This will be how much? Just check. 4.66 whole square. This is a huge number. This cannot be done orally. Just check. So, but did you understand? This is how you will calculate the magnitude, even if you want the direction. So, direction I have told you. For direction, put angle as beta. Now, put tan beta will be what? It will simply be fx divided by fy. Remember, for 90 degree special case, we did tan beta as b by a. So, this becomes fy divided by fx. And fy was what? 6 divided by 4.66. So your beta will be tan inverse 6 by 4.66. Like this. So magnitude will also be there. Now you have the resultant net force. So this was widespread. You didn't know what was the answer. Now you initially, I'll just repeat it once more. Let me know wherever you're not able to understand. F1 got resolved into F1 cos theta here, F1 sin theta here. Magnitudes 5 root 3, magnitude 5 Newton. Angle 30 degree was made. So the axis with which the angle was made was termed as cos theta. Come to F2. Angle with which it is made is x-axis. So that becomes cos, perpendicular one became sine. Values we have as 3 and 4. F3 was already in the downwards direction. So we need not resolve it because it was already pointing towards the y-axis. When you resolve it, you get ultimately you have these. Now you cannot even solve these further, but at least one thing has become easier over here, that you can choose one direction as positive, other as negative. Whatever result you will get, that will be either the component along x-axis or the component of force along y-axis. So fx came out to be this, fy came out to be this much. Fine. So now technically you just have two forces, fx and fy. So net force will be what? Use your parallelogram law, put cos 90 degree as 0. Then it will be only under root a square plus b square. That will be under root fx square plus fy square, right? And tan beta, you can calculate the direction. This is how we use resolution of vectors. For example, this let's say this was a question of your laws of motion. Let's say we were not doing resolution of vectors, but without, do you see, without understanding of resolution of vectors, you will not be able to solve the question further. Did you write the above question? From here, copy it down. So this was the resolution of the vectors in 2 dimensions. If you have to resolve it in 3 dimensions, 3 dimensions means if just additional z-axis is there. We had only 2 axes over here, x and y. If just in case there is a third axis, that is your z-axis. Or you can even say rectangular components in 3 dimensions. So lastly, whatever will be the statement that you have to remember, but it can, there's a very least chance of this question asking in your exam. Just check in your class notes in your school whether this topic is done or not. If by chance this topic is done in 3D, then mark it as important. But if it is not done, then no need to do the derivation. If it is not done, then the school won't give it. Now let's say 3 axes are there. This is your z-axis, the extra axis that we have. This is the y-axis. This is the x-axis. Fine. Now, here, let's say, let me erase certain axes, otherwise it will become very confusing. Z-axis, now certain angles are given. This is not the axis, this is vector A. Random vector A I have taken. Fine, so this is the vector A. Let's take the angles. This is alpha. Angle between A means your vector and the x-axis. Then this is, let's say, beta, angle between the vector and the y-axis. And let's say between A and Z, this angle is gamma for our calculations. Fine. So alpha is what? Angle of A with respect to x. I hope I don't need to write that. You'll be able to figure it out. What is the angle between what? All the axes are making angle with the vector A, which are as follows: x, y, z, alpha, beta, gamma, respectively. Fine. This way. Now, few things you have to remember, which include the fact that AZ, this becomes equal to A, opposite one. What's the opposite one? Alpha, A cos alpha for 3 dimensions. 3 dimensions means if you have Z axis along. So AZ will be A cos alpha. Similarly with AY, see AY will be, it won't be having any opposite because these two are already considered. So this is along with not Z, just this is a x. Alpha is made with the x, no? See, this is alpha, this is made with the x-axis. So this is ax. Ax is A cos alpha. Y is what? A cos beta. Z is making what angle? Gamma. So AZ will be A cos gamma. This is how we resolve. End of it. No need to consider sign, nothing. This is the end of it. The AX, AY, AZ. If you want to find your vector way, your vector A is magnitude. This will be directly under root AX square plus AY square plus AZ square. In Cartesian form, we have studied. Yes, class, we have studied in this way. If your vectors are there, magnitudes are present, and how to calculate their magnitude. You take the coefficient, you square it. Remember I caps coefficient, we used to square it, then k caps coefficient, we used to square it, and add with the z squares coefficient. So do the same thing. Don't forget your Cartesian form. And class, I'll be taking a test of your complete vectors. Vectors I've done with all of you. You all were present in the class of vectors. For vectors, today is Friday 2nd. You have your class on 5th. 5th we'll study. 7th, 7th also we'll study only because you people are having exams in the next week, no? So yes, let's take your test on 14th. So it will be a revision for 17th paper as well. And for the students who will appear for their exam on 11th, their vectors will already be prepared. Or 7th, let me know. 7th or 14th, what do you say? This Wednesday which is coming, so that all of you will get a revision for your exam, or 14th? Say class, whatever you will say, I'll choose the date.
7th.
7th is better, no? Yes, I'm thinking the same because these two students are having their exam on 11th. So it will be a complete revision of vectors. Fine, on Wednesday we'll have a test. 7th we'll have a complete test. Fine. So because all these things will come. Now see, cos alpha will be what? Cos alpha will be directly ax divided by the a. See, if ax is cos alpha, so cos alpha will be what? Just reverse of it. If it is used somewhere, if you reverse this, so cos alpha will be what? It will be ax divided by a. Similarly, cos beta will be what? Ay divided by a. Cos, what was that? Alpha, beta, gamma. So this is az divided by vector a. This way you have all the vectors present. Now see, if you square and add all these vectors, square and add them. Cos square, this part, no, we are doing after this. This is a proof what is the square of this. I'll tell you how the question comes. Cos square alpha, cos square beta plus cos square gamma. And also class, it's better if you people get your previous year's papers of your schools. So you will have a complete idea. Some questions always repeat. And this cos alpha square will be ax by a whole square plus ay by a whole square plus az by a whole square, right? Now from here, if you write ax square plus ay square plus az square together and divided by a square, there won't be any effect. I've just separated the terms. What is the magnitude of a square? See, magnitude, a vector was what? A vector's magnitude was under root ax square plus ay square plus az square. So a square will be what? The square will get removed. Ax square plus ay square plus az square. Put the value of a here. So cos square alpha plus cos square beta plus cos square gamma will be what? This will be ax square plus ay square plus az square divided by a square, and a square is what? This is also ax square plus ay square plus az square. So in the question, in your exam, it is asked if you resolve all the forces along x-axis, y-axis, z-axis, prove that cos square alpha plus cos square beta plus cos square gamma is equal to 1. This is it. Fine. Note this down. This can be asked. And if it has come in your one of the exams, or if your teacher has done it in your school, then this becomes very important, because this is a part, 3 dimensions. Fine. So from here you have to note it down. No? Note.
Ma'am,
Yes.
ma'am, why is the cos square is the cos beta squared?
It is just this one. Why we have squared it? Because see, we are just proving, we are trying to prove that if actually the questions will come in this form, cos square alpha plus cos square beta plus cos square gamma is what? Or if it is 1, then prove it. So we already have this. We already have cos square alpha, cos square beta, and cos square gamma. We are just trying to prove through our derivation that yes, the sum of all these three angles which are taken for the rectangular components for all these angles, it will be the sum for all these, not just the sum, the square of the sum will be 1. But it's not like we have this part with us, and this is a certain, there's a certain logic behind why we are squaring and adding. It's that we initially have this with us. We are now trying to prove why is this equal to 1. Got it, Fatma?
Yes, sir.
One question let's do, then that will be the last question for resolution of vectors. So then I'll leave you people, I think. It was just 1 hour, 1.5 hours class was enough. So we are just left with dot and cross product that we'll do on Monday. So A vector is 2I cap minus 3J cap plus 4K cap. Now you have to calculate magnitude of A. First part. Second part, you have to find out the direction cosines. Now, what are direction cosines? Direction cosines are what you have just written. I'll tell you. See, for the magnitude of A vector, we take, it's a revision, so pay attention. Square of the I cap first. I cap is 2, this becomes 2 square, plus square of j, coefficient of j cap. So this becomes minus 3 whole square, plus square of coefficient of k cap, that is 4 square. This is what? 9, 4, 16, 29. So this becomes under root 29. Now second part says direction cosines. Direction cosines means find cos alpha, find cos beta, find cos gamma. Cos alpha will be ax divided by a, magnitude of a. Ax is what? Coefficient. See, this is ax. Ax I cap minus ay j cap plus az k cap. This is the standard equation from where we had started the Cartesian form. Ax means the coefficient of I is 2. This becomes 2 divided by 29. Cos beta, this is a by divided by a. Coefficient of y cap is minus 3. So this becomes minus 3 by under root 29. And this is what? This will be cos gamma will be az divided by a. So az is what? 4. 4 divided by under root 20. Like this. If in the numerical it is as maximum this can be asked. Otherwise, your resolution or vector of vectors are confined to that question, force question which we did. It's noted down. Just text me when you have done. All of you, when you've done writing the part, just text me. I'll stop the class. What about others apart from Aram?
I'm done.